Hello everybody and welcome back. Well, I got a new one starting today and this is a weird one. I just got this all unboxed. This is from PSE, is it? Project Precision Engineering or something like that. PSE. Oh, I forgot what this company's even called. PSE. I'll have to get back with you on what that stands for. Something engineering. This is called Bazooka, which I did a little bit of research on this game, and it looks like a really cool game. It's an old 70s, 1977 Project something engineering. I just can't remember what the full name of this company is. It looks like a really super cool game. It's from 77, I believe. And yeah, so here we have, this is a primitive cage type deal. We have a cage with the power supply right here. And there's 3 slots for boards. The boards are right here. So there's 3 boards that plug into this thing. And this thing is kind of a mess, to be honest. This is how I got it. It looks like it's missing a 3-position plug for the AC, because this is a big rectifier. And this is the AC coming into this rectifier. Yeah. And it's missing. This looks like it's supposed to be 2 capacitors. And somebody put these in here. And I don't know what's going on here. This is supposed to be positive for one of the caps. This is supposed to be positive for the other cap. And these caps are just put in across the 2 positives, which is not going to work. This has to be redone. It's supposed to be 2 caps. The negatives are in the middle and the positives are on the outside. So, I mean, you could have it like this. I don't even know if these are the same circuit. I don't think that they are. They are not. This one is for negative voltage because the positive is grounded. So this one filters a negative voltage. This one is filtering a positive voltage. So they're not the same circuit. So it has to be two different sets of caps. So that's got to be changed. We're missing a diode right here that was taped to the cap, this big cap. This cap looks like it's been replaced. I think we're missing a part that goes right here. I do have schematics for this. So this is another rectifier. I would say this is probably the higher voltage, like the whatever voltages this might have, like 20 some volts or whatever. These caps right here are probably for the higher voltage, positive and negative, and this is probably your 5-volt circuit right here, I would imagine. We have a big input I/O plug probably here. I don't know what this is. I don't know what any of this is. I gotta look at this on a schematic. This cap's been replaced. Yeah, so it's kind of a mess. We got some hacky stuff going on down here. I don't know if this is factory hackery. The pass transistor for probably the 5-volt current transistor is the regulating transistor, if you will, is unhooked. Looks like it has been replaced. That does not look original. So, and I don't see any. It looks like the collector is tied right to this. Looks like the collector is hot on this board here. So, because I don't see a insulator behind this. I don't know if it's supposed to be that way or not. My intuition tells me that it should have an insulator. This is actually tied right to the collector. So that goes there. Yeah, weird. Okay. I can fix this stuff. I fix this. I really want to look at a schematic for this. And look at this power supply. I need to identify this part. What goes here? This, I take it, is the diode that came out of here. I don't know. It's probably just a standard 4007, I would imagine. Get these caps removed. Find out what these values are. This is just like a 5500 or something like that. Nothing too spectacular. That's an easy replace. So, yeah, that's what we'll do is look at the schematic, go over this power supply, look at what we're looking at. I would like to see a diagram, what kind of plug. It's obviously one of these sort of 062 or whatever these are. 6 position 062. I do not believe I have anything like that, but I'd like to look and see what does that look like. What is it supposed to look like? Can we replace it? Or is this just going to have to be... Where's the AC coming from? That's another thing. This has an AC transformer, obviously. So the AC is going to plug into here from the transformer. So the cabinet that this is at has that mating plug, is what I'm getting at. And we might have to change that. If I can't get the exact plug, we might have to change the plug on the transformer side to match what I can put here. So I'm going to have to look into that, see what that, hopefully try to find out what that looks like. Can I get an exact replacement? I don't know. We'll have to look into that. So, all right, I'll be back after doing a little schematic research, get some part values and stuff like that. All right, we are looking at Bazooka. 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 Active 10 volts. See that? That right there? Active 10 volts. This is not ground. It's a heat sink, and it's active. So that is how it's supposed to be. You have 10 volts, and which is going to be more like 13, 14 volts in today's electricity. On the collector, and this is a pass element. So the current passes, an amplified current will pass from collector to emitter through this thing. And the emitter side should be regulated to 5 volts. So that's what that is. And this is actually active. How about that? There's our plug. Remember that 6 position plug? So I'm thinking that looks kind of like a standard 6 position. And you know what? I might be able to scavenge something like that. But the thing I don't have is I don't have the solder tail. I don't have solder tail pins to do that correctly. So I'm going to look into sourcing something like that. And I'd like another photo or something of that. I'll try to do some more research. Here's the two big caps that were replaced with the one cap going across the two positives on our board. So that needs to be fixed. Those are two capacitors there. So we got control harness. We have main harness. There's your 5-volt adjust. Your boards. 5-volt rectifier. 12-volt rectifier, just like I had thought. So this is going to have probably a negative 12 and positive 12 voltage power supply. Because this one, you could tell because the positive is grounded. So that is filtering a negative voltage. And this one is the opposite. So this is your positive voltage filter. With a 24 volt span. 24 volt span from negative 12 to positive 12. With your reference right smack dab in the middle, ground. Okay, that's the TV. Let's go down a page maybe. Page down. Oh, that is the bottom. Prom busing. Power supply prom busing. What does that even mean? Motherboard video circuit. Motherboard video circuit. So the video circuit's on the motherboard. Is that what that's getting at? Okay, here's that. Here's that 741, and that is biasing. See, here's the regulator circuit. You have this 741 op amp, which is providing the bias current, and this is your. Boy, this thing's acting really stupid. Must be needing to be charged. 10 volts unregulated at the collector of that transistor on the back of that cage, and your regulated 5 volts is on the emitter side of it. So this is basically controlling. This is biasing the bias transistor, and the bias transistor is biasing the current pass element right here, which is kind of controlling the amount of current that goes through this thing to the 5 volt regulated circuit. Okay, LM323, LM323, there's two of those. I don't remember seeing any of those. LM340T for 12 volts and negative 12 volts. LM323, those are TO3. I think those are those TO3 LM323s. I don't see any of those at all. So I'm going to have to look again, because I don't remember seeing any of those. Here's those two capacitors that were replaced, and unfortunately there is no values. Why is there no values on this? It's just capacitor. My guess is they're probably 3300 microfarad caps, because that's what was put in there. Because this one is a 5500 microfarad cap. This is the 5 volt filter. Look at this. You got two 5 volt circuits here. LM323s, 2 of them. I'm going to have to look at that again. 323, is that actually like a T0220 package, kind of like the same as a 1 volt or a 1 amp, 1.5 amp regulator as these are? That might just be like a 7805. I don't know. Maybe the LM323K is the TO3 version. We will have to see. I don't understand what all of this is. What is this? D2. I don't remember seeing anything like this on there. And then you get into your boards. This is board 3. This is like the audio board, I believe. And this is board 2 with a big smudge. And there is another version of this schematic, I believe, that probably doesn't have the smudge. We'll check that out. And board 2, board 1, board 1. So you got 2 pages for board 1, 2 pages for board 2, and 1 page for board 3. This is power supply and busing. I don't understand what these chips are. I don't know where these are. They're not on the that power supply bus, I don't think. I'll have to look at it again, I guess. So okay, yeah, let's take another look at this thing. Okay, interesting turn of events. This is the 5-volt filter cap. These two are the 12-volt, the lower volt filters. They're the higher volt filters, actually. Lower current, higher filter, higher voltage. The 12 and the negative 12. This is the 5. This is the negative 12 regulator. That's kind of as far as I've gotten, just doing some beeping out and tracing what's what. I removed these. Yeah, so these were across the 5 and the negative 12 filters. Okay, so I'm going to keep on finding out what's what. Okay, and once again, I have found through the manual that I found online this more detailed power supply schematic. And it does have our values, which I find kind of strange. Here's the plus and negative 12 supply. And the positive 22 volts has a 9600 microfarad cap at 25 volts. Whereas the negative 22 has a 100 microfarad cap at 35 volts. What kind of crazy engineering is that? And this is, by the way, it's project support engineering. Why in the world would they have a 25 volt cap across this 22 volt, yet a 35 volt cap across the negative 22 volt? Here's our 2 regulators. And just jumping in here, I wanted to also taking a look at this. The negative 12 volt circuit is not even right. There's no ground going to that regulator at all. It's just got an input and an output. No ground. It looks like it's the same part number as the positive regulator. And it's only got the little 100 microfarad cap on here. It's like this schematic's not right. Because the way that that board is made, it is made for a 7912. It's got ground to it, it's got everything. So I don't really know what's up with that. But anyway, yeah, I just kind of wanted to jump in, and that's pretty weird too, that just wasn't right. Anyway, back to it. and some other caps, whatnot. Yeah, so I mean 10,000 microfarad, that ain't nothing. I've got those. This one, I don't know. I'll probably up the capacitance to maybe 4,700 or something like that, 1,000 microfarads or something like that. I don't know. I don't like that 100 number, really. It's kind of strange. Here's the unregulated 10 volts, which is another 10,000 microfarad cap, 25 volts. And up here is the 10 volt power supply, or the 5 volt. So you have your unregulated 10 from down here coming through up here, and it's common collector transistor circuit is a current amplification circuit. The regulation is done on the emitter side of this transistor. This is the biasing circuitry, and that diode that I said was probably a regular 1N4007 is actually a Zener diode of 3.3 volts, which is biasing the voltage on this op amp. And how does this work? How this whole thing works is this is going to be basically clipped at 3.3 volts. And this one right here is controlled by a pot. That's your 5 volt trimmer pot. So based on the input of this one looks like it's a fixed 3.3. And based on this one, the voltage on this one will change the output to biasing this transistor, which will in turn bias the output of the 5 volt circuit. So that's that. So that I do need to make sure that I have a 3.3. I do think that I have 3.3 volt Zener diodes, and the Zener end of it, the cathode, goes to pin 3 of our 741. So that's that. So I've got everything that I need here. I've got all of the info that I need for that there. And this is the manual now. This is it's got split schematics. There's board 1. Remember, there's 2 pages of board 1. Program counter. I don't remember seeing that. Board 1. Board 2. Board 1 still. This might be a more complete schematic. I don't know what's going on here. Board 2. Remember, there was 2 sheets of board 2. So that's 1 sheet. And this is the second sheet of board 2. And, well, that's board 3. I don't remember. I don't see the big blotch, which is good. So this one does not have that big black blotch in the middle of it. Sheet 2. So that's good. Okay, and there's this that we got. There's our 6-pin connector. Okay, yeah, this does not look, these look like all the same caps. I think that's got to be a typo. I think that negative voltage, that negative 12, is probably the same cap. And remember, this one's a 5500 microfarad cap that I pulled out of right here. It's 55. It's not 96. It's not 100. And this is the negative filter. And the one that was in the board was 5500 microfarad. So I think I will replace this one, which is the 10 volt. I will put a 10,000 microfarad there, and I will put like 4700s or something in here. That's what I'll do. And I think that'll be fine. And then I'll replace the other parts that are missing, or I'm going to replace those negative and positive 12 volt regulators just because. And I'll test that 3055 pass element. I'll test it and then I'll wire it. Remember, the wires weren't even in the board, so get that thing wired in good, and we'll be able to actually build a harness for this thing maybe. And I can test the power supply. I can maybe put a load to it and just test it. I think that's what I'll do first and foremost, is I will build the power supply, and then I'll load it and I'll test it. Make sure it's putting out good voltage. And then, yeah, because if the biasing circuit, the 741, the bias transistor, if that stuff is not working properly, you'll pretty much get 10 volts on the emitter for your 5 volts. So I don't want to send that to the board, so I want to load it down and then test it. And put it right at 5 volts, and then we'll go from there. Okay, making some progress. We have, I don't have a 3.3 volt zener, but I do have 3 volt zeners. So I put a 3 volt zener in with the cathode towards pin 2 or 3, whichever it was. I think it was pin 3. So the cathode is towards pin 3. I removed that 741 amp because I did not like the way that this pad looked right here. This one was really not tinned at all. So I removed that. I tinned this, make sure it wasn't broke. I'm going to put a socket in place. I removed the 2 tantalum caps that were in these 2 positions here, as they filter the voltage coming off of these 2 regulators. Those tantalums are right here. I don't want them blowing up, so I'm going to replace those with electrolytics. I made a couple of aluminum heat sinks for my regulators and got on there. I do not want those screws touching. Those screws cannot touch, because if they do, one of them is negative voltage and the other is ground. So those cannot touch. So I'll have to figure something out there. I might even, well, I can't, well, I don't know. Let me figure that out. Anyway, so I'll go ahead and finish this. I got my caps in. It doesn't look beautiful, but it's okay. These are 4700 microfarad. This one's a 10,000. This is the 5 volt filter, and these are your negative filters. Tested these guys. They're fine. I did a lot of resoldering. I resoldered all of this on the bottom of this. I've yet to clean though. I just resoldered all of these connectors and everything. All of these. Crack joint galore on this. So I got everything resoldered. I still have to solder in this guy. I need to test it. That's it. We'll get it figured out. I may have to put nylon screws in here. I might have to remove one of these so that I can put nylon screws in, because these screws, those 2 screws cannot touch. If those touch, you got a direct short between a negative voltage and ground. So for safety's sake, I'm going to have to remove one and put nylon screws in both of them. So just noticed that just now. Alright, well, that's a little progress update. we'll keep going on it. And there, that fixes that. 2 nylon screws in there. No chance of them touching now. Okay, so continue with these. These were originally 1 microfarad tantalums. I'm going to replace them with 2.2 electrolytics. Put that socket in. And then I just got to come up with something for over here. And I got to finish this. I went ahead and replaced the wires. I tested this transistor. It is good. It looks new. Someone had put this in. I replaced the wires with good solid core wire. This wire that was on it is too thick. It won't even fit through these holes. It's just way too big for this. So I went ahead and used some good solid core wire and made good mechanical connections on the transistor and soldered it. This is the wire for the collector. It's crimped good and soldered. There you go. So I'll put this thing back together. I only got red and black, so I'll just have to make sure that the right wire goes in the right spot. No big deal. And this thing will be done. I'm going to put a new 741 in it. It looked like it had been replaced, but it doesn't matter. They're cheap enough. I'll go ahead and put a new one in. Alright, I'm going to be really honest with you. I do not like this being hot with 10 volts. There should be an insulator on here. There's no purpose for this being hot. So what I'm going to do is I'm going to fit a socket, a TO3 socket. Right now this will not fit in here because these holes are not big enough. I'm going to drill these holes out so that this socket will sit in here on the other side, obviously. So that it'll sit in here. I need to drill the base and emitter holes out a little bit. And I'm going to put this TO3 socket in. And that's how we're going to go with it. This should not be a hot heat sink. That makes no sense. So we're going to do that. I'm going to drill these out. We'll use a mica insulator against this so that it insulates this from this. And you don't have to worry about shorting out. You don't have to worry about touching this and getting a zinger or nothing like that. So yeah, this just doesn't make any sense. So that's an upgrade in the making. I can't believe this was manufactured this way. Shame on you, project supply engineering or project support engineering or whoever that was. Why was this not insulated? Right, I'm going to replace that TO3 2N3055 part. I'm going to replace that with a part that hasn't been soldered because it goes into a socket better. But this is a 2N3773, which is a better rated part. It's just a better part altogether. And this is from On Semiconductor. This is from Mauser Electronics. This is not a counterfeit part. I don't know about that other one. It just seems kind of generic. So I'm going to put a real good part in it. And here you go. Power supply rebuilt. Caps. Oh, we'll figure something out. All of this is done. These caps. My nylon screws in there with the heat sinks. Looking good. This is beautiful. I drilled out this back plate to accept this socket. This is the base lead, which is the end. That's your bias lead for the base. double checked, double and triple checked, make sure it's wired right, and it is. I had to put some new screws in. What this really needs is like through-hole nut and screw. The screws that were in here were not sufficient. They just would not hold this back plate on, so I put some longer ones on. I actually had, the only ones I had were too long, and I had to cut them down. You can see I cut these. I cut these screws. All 4 of them. Is what it is. It's in there really good though. It ain't coming out. This guy mounted in there with a insulator and heat sink grease. And added the socket, of course. Had to use a, I believe it was a 7/32 drill bit, I believe was the size to drill that out. These heat sinks, I think I had to use a 7/64 drill bit to tap the 6x32. So I drilled and tapped these, and I had to drill that out, so there you go. So this thing is ready. I put a new 741 in it. This thing is ready to be load tested. I just got to figure out a way to put AC to it. This gets, according to the schematic, I believe it was like 16 volts and 8 volts. Something like that. But there's no center tap. It does not, it has to have a center tap, right? I don't know. We'll look at it. I got to look at the schematic better. But this thing's good to go. This thing's done. Done with it. Very happy with the way it came out. Okay, yeah, I don't have this connector. Just don't have it. It's an 062, I believe. It's an 062 6th position. This is 062, I believe, right here. I think that's what goes there. But for testing purposes, I'm going to wire in connectors to connect to my midway harness, because this is basically the same thing that we're dealing with here. You can see these windings. This is the center tap, and then you have the higher voltage windings on the 12 volts. So it goes center tap, and then these are your 16.5s, and your 2 inner windings, your 9 windings, go here. So that's how this is. And I did check. It shares the same center tap. This is center tap right here, 3. And all of the voltages share that same center tap ground. So it's not like it's 2 separate circuits. It's all working on one big winding. So I can use this guy right here. And I'll just wire in temporary something to hook to this just to be able to test this. And I'll put my I'll build some kind of harness to put my resistor, my load resistors on here, and we'll test all the voltages, load them all down and test everything. I might replace this little pot right here. The little 5-volt pot is a 5K. That's a 5K pot. And since I have a 3.3 volt or a 3 volt Zener instead of a 3, I want to be able to change the voltage to dial it in, and this has got all kinds of glue on it. So I may go ahead and replace that with a 5K pot before testing so that I can actually adjust. Because this was factory glued, but I want to be able to adjust. So I'll do that, get my wiring all together. We'll be ready to load this thing down and test it out. Okay, I got good news and bad news. I got my plug-in. You can see that yellow wire, which is the yellow wire is the center tap. The center tap is kind of burned up because when I had the lower voltage plugged in, it freaking smoked. But the good news is, right now, the 12 volts is fine. Here is 12, and here's negative 12. But maybe, just maybe, this is on a separate winding. And it does not share the same center tap. So I got this other 12 volt and 0 winding right here. I'm going to try that. Okay, so I've got the 12 and 0 volt winding. It's totally separate from that other winding. It's its own deal. So we're going to see if, because looking at this schematic, I just assumed that they shared the center tap, but maybe they don't. So let's fire it up and watch for smoke. See if this thing smokes again. Here we go. I do not see smoke. Let's check for 5 volts. No, I don't see 5 volts. All right, let me look into this. All right, actually, I just wasn't getting a good ground here. This is 5 volts, and I'm still not getting a good ground. I don't want to short anything out. Hold up, hold up. I can't get this thing to ground. There we go. See that 5.24? That's where I set it at. I set it at 5.24, so when I load it down, it will, you know, the voltage will drop. This is the collector. That's it's 18 volts on the collector. Because I'm using, instead of, it says, I don't know what this is supposed to be. It's supposed to be lower than 12. But that'll be fine. It's regulating. It's working. The regulating circuit is working. So I want to go ahead and load this down. Yeah, that's a separate winding. It does not share the center tap. I thought it did. It doesn't. And when I first fired this thing up, I mean, it smoked. Just, full disclosure, that thing smoked like crazy. I wasn't filming, but it was like, it wafted just smoke bad. It was crazy. But it's okay. So that is a separate winding. All right, let's load this thing down. I got to figure out how I'm going to load this thing down. Where I'm going to grab power from, how I'm going to do it. Maybe I'll have to see if power goes onto this. We'll see. Let me do a little research. Okay, well, I had to basically just solder to the back of the board on like where the power is on these. I just soldered wires and brought them out. So that's how I'm doing it. I got loads on. This is basically a 3 3/4 amp load on the 5 volt line. So that's more than this thing will see. So if it tests good at this amperage, it'll be fine. We have 24 ohms. 24 ohms divided by 12, or 12 divided by 24. That's half. half an amp. 24 ohms. Yeah, 12 divided by 24.5. That is half of an amp load on, I believe it is negative 12. And then I got like 51 ohms or something like that, which is 250 or something like that milliamp load on the 12 volt line. I should probably swap the 12, and it doesn't matter. They're 1.5 amp parts. So, you know, that's about what they'll see, you know, milliamps. They're not going to be putting out that much power, so it's all good. We are completely loaded. Now 5 volts does come out to here. The other 2 voltages does not. So I can test my 5 volts right here. And that's what I'm doing, getting ready here. So let's go ahead and fire it up. Power supply test. .94 volts. And it's loaded at 3 3/4 amp right now. Because it's got 3 4 ohm resistors, but they are in parallel, which means they divide. So it's down to like 1, almost 2 ohms or something like that. The power supply is doing good. Let's check the other voltages. There's your 12. And here is the negative 12. So yeah, go ahead and set this back in here. There we go. And we're checking out our 5 volts. So, success. I'll go ahead and let this run for a little while. I'll probably let it run for an hour. Loaded. Then we'll be able to be ready to move on to the board set. I actually have to build a harness to actually display this. So it'll be more of looking at the schematic and everything. I'll go ahead and upload this as the power supply repair. We're looking good. It's done. Good to go. Project support engineering. And yeah, this is not hot anymore. That says millivolts, by the way. There's nothing there. Yeah, I didn't like that. There's no reason for that to be energized. No reason for this to be energized at all. All right, I'll go ahead and upload this as the power supply repair. We'll see you on the board set repair. Thanks for watching, everybody. If you get anything out of this and you want to help support the channel, check me out over on Patreon, patreon.com/classicarcaderepairs, and there are always channel memberships. Appreciate every one of yous. Thanks a lot, everybody. Have a great one, and we'll see you on the next Classic Arcade Repair. Bye for now.